y equals 4x squared plus 1 raised to negative 50. Fine. So let's write the rule now with a function. This is, and you can say, what about x? X is a function as well. Yes, it is, but it's the simplest possible. So if a function, any function, raised to power n, needs to be differentiated, we want to find the rate of change of this function. Can anyone dictate? It's okay if you're wrong.
Will that be negative 50?
N.
Oh, you're doing this.
Yeah, just this.
N times f, and then n negative 1 times f prime.
That's it. So please always say what I say. N times f to n minus 1 times the inner function prime times the inner function prime. So always keep these words in mind. Times the inner function prime. So now we have the function here. Can anyone else? I heard from Yulia and I heard from Sloan. Anyone else would like to give it a shot? I think I heard from Ben, Levi. Who would like to just try this based on this pattern?
Negative 50
Awesome.
times 4x squared plus 1 to the negative 51.
Awesome. Times the inner function prime.
Times 8x.
Brilliant. That's it. That's all we needed to do. Yes, I can rearrange. It's a product. So negative 400x, 4x squared plus 1 to negative 51. That's it. N times f to n minus 1 times the inner function prime. Okay, now we can move on to other more sophisticated examples. So let's choose a product. No, not the product yet. I want to choose the radical. So let's do the radical. Let's say 5. I think I'm on page 3. So 5. So we have y equals the square root of 3x squared minus 4. Okay, very good. So now let's analyze this new rule. Forget about the problem one second. Again, can anyone tell us what did we just discover for the square root of x prime?
Is it 1 over 2 square root of x?
Times, I never told you. I didn't lie, but I never told you to do this. Why?
Because it's 1.
Because it's 1. I should have said times the inner function prime. I didn't. I didn't lie to you. But I didn't because it was 1. But now we have a different story. Can anyone give us the formula for the square root of a function prime? You only have to watch this and mimic the pattern. Give it a shot.
1 over 2 f the square root times f.
The square root of?
F.
Very good. I just didn't hear it. Forgive me. Times?
Times f.
Times?
F. F1.
F prime.
Thank you. Thank you. Times the inner function prime. Not times the inner function. Times the inner function prime. Maybe that was not very clear here. It's my fault. Good. So now let's uncover it and write the square root of 3x squared minus 4 prime. Who would like to give it a shot? I love the interaction with my students. I don't want to just move on. I want to move on with you.
Will it be 1 over 2 square root of 3x squared minus 4
Times the inner function prime.
a 6x?
Excellent. That's it. Great job. Any questions? Any questions? Okay. Now let's move on and let's choose a product and a quotient. We can choose this product if you like, or any product and a quotient. Any quotient.
Yeah, let's do 19.
19. Let's do 19. And we have f of x equals 5x plus 2 to the 4th power 2x minus 3 to the 8th power. Awesome. Now things are getting complicated. Why are things getting complicated? Here's why. I have the product rule. Then I also have the chain rule with this. Chain. And the same thing here. Chain. So first of all, I have to follow the product rule. And every time I differentiate these pieces, I have to use the chain rule. So f prime of x. The product rule says differentiate this. Can anyone try to differentiate this for us? See, that's why I have my props here.
Will it be 4 times 5x plus 2 times 10x plus 3
Good. Times
times,
the inner function prime.
so it will be 5
That's it. Times the second function plus. I'm writing it here. It's not two pluses. It just tells us that it continues somewhere. I don't have enough room. I have to copy the first function times. Can anyone differentiate this for us? Other than Tariq, I know he got it. Thank you.
Would it be 8 parentheses 2x minus 3 to the 7th?
Times the inner function prime.
2.
That's it. Awesome. Any questions? Any questions? Well, we need to continue and simplify this one though. Okay, so I'm on page 4. How many terms we see here? This product is one term. This product is the second term. Do they have common factors? Common factors. Do you see the same thing here as well as here? Yep, I see a 4 that is common. Do you see 5x plus 2? Yes. How many are common in both?
7 total.
In both, how many are common? Common. So you have this in your pocket, and I have this in my pocket. What do we have in common? How many we have in common?
1.
3.
3.
Oh my god.
So you have 3, and I have 4. So in common, we have 3. I have 1 more. But in common, we have 3. Good. Also, I see 2x minus 3. You have 8. I have 7. How many we have in common?
7.
7 we have in common. You have one more than what I do. Good. Now we open a bracket. From the first term, 4 is out. These are out. 5 is still in. From these 8, I pulled out 7. How many more are still left in?
Just one.
Exactly. I have to copy 2x minus 3. I reached the plus. I continue underneath because I don't have room. I always run out of room. You know that already. From 4, I took out 4. From 8, I took out 4. So there is a 2 left. But 2 times 2 will be 4. All these are completely out. But from 4 of those, I removed 3 and I put them in front. So how many are still left inside?
Wait, how did you get the 4 again?
You mean this
Is it-
4?
No, the other.
This one. So this is 8 times 2 is 16. And I pulled a 4 in front times 4. It will be 16. So I had 16, but I pulled 4 in front. So I only have 4 inside. Is that better?
I'm not sure. I'm still confused.
So
What do you mean, like doing 4 from there? I understand you got 16 from like.
so let me write this. We're going to finish it in a moment, but let me write this again. 20, 5x plus 2 to the third, 2x minus 3 to the 8th, plus 16, 5x plus 2 to the fourth, and 2x minus 3 to the 7th. The 20 and the 16 have 4 in common. This will have a 5 left, and this will have a positive 4 left.
Oh, okay. So you just skip a step. Okay, okay.
So that's a very good question. Maybe I should have written this first. I thought everyone could see it, but maybe not everyone could see it. So sorry about that. So is that clear? 4 times 5 is the 20, and 4 times 4 is the 16. Is that better?
Yes.
Thank you. If you don't ask questions, I would not know what I need to explain sometimes. So please help me with that. Thank you.
Okay, I have a question.
Sure.
So up here, you have the 4 and then the parentheses open and empty. What is that?
I didn't finish because I wanted to answer the question before continuing. I was answering a question about this 4 here. I didn't finish. I said I was coming back. Is that clear, Rakita?
No, but I'll continue.
So what I was saying is there was a question about this 4. And I said, I will come back to this step after I explain where the 4 is coming from. So I showed where the 4 is coming from, and now I'm back here. Is that better now?
Okay.
So let's continue. So we figured out what where 4 is coming from. The 5x plus 5x plus 2 to the 4th power, we only took 3 out, so we still have 1 in the middle. But we had 2x minus 3 to the 7th that we pulled out completely. So now, you know my style. I'm just going to jump over this and continue here. So the factors in front are 4, 5x plus 2 to the 3rd, and 2x minus 3 to the 7th. Now I distribute 5 times 2x, 10x, 5 times negative 3, negative 15, plus 20x, and plus 8. And now I change the bracket into a parenthesis. There is no need for brackets anymore. 10 plus 20 will be 30, and negative 15 plus 8 will be negative 7. So the final, yes, go ahead.
Let me go up. I can still see the top of it. Yeah, thank you.
Is that better? So this was just a parenthesis, if you want, just a side explanation. From here, we jump here. So this is 4, 5x plus 2 to the third, 2x minus 3 to the seventh, and we have the 30x and minus the 7. So from this moment on, there is no calculus. This is just what we learned in algebra. There is no calculus here on this page at all. Okay, do we understand how the chain rule works? Do we feel a little bit better about the chain rule? Yes?
Can we do number 17?
Yes, 17. So in 17, we have f of x, negative 5x to x minus 3 to the 4th. Okay? Good. So I see again the product rule. This is one, and this is the other. Product rule. So then f prime of x. Can anyone differentiate the first function for us?
-5.
Good. Then I copy the second one. And then I should write minus, but let's write plus for now. Copy the first one. Can anyone differentiate this?
Four parentheses 2x minus 3 to the third.
Times the inner function prime. Always say that to yourselves.
Times 2.
Excellent. It's always times the inner function prime. So we have -5, 2x minus 3 to the 4th. 4 times 2 is 8, times -5, negative 40x, and 2x minus 3 to the 3rd. This is just algebra. Now we see a common factors. So this term and this term have common factors. Let's pull out those common factors. Can anyone help with those common factors?
Is it 5?
5 is the first one. Let's put negative because both of them are negative. Awesome. What else?
2x minus 3 to
Oh.
the third.
Excellent. And now let's open brackets. The -5 is out. From these 4, we removed 3 of those. They're out. Is there anything left?
It's just 2x minus 4 minus 3.
Excellent. From -40, we took out -5. So it's positive 8 left in. -5 times 8, -40. But also an x. From these 3, we took out 3. What is left? You can say nothing, but the nothing really means 1. And I agree with nothing, but the nothing is not 0, is 1. Good, we combine like terms in brackets. And we get -5, 2x minus 3 to the 3rd, 2x plus 8x, 10x minus 3. Done. Very good pick. It was a very good example. Much easier than the first one. Awesome. I'd like to talk about something like this. So we know what this is. What is this? Because you're going to encounter this in MyLab Math. Okay, so as I mentioned when we started the chain rule today, where's my page with the chain rule? I said there is more to this, not just this power rule combined with times the inner function prime. So there is more to it. Allow me to